Welcome to the lesson on verbal phrases and algebra. In this lesson, we will discuss how we can connect written words and situations into mathematical expressions and equations. So by definition, we know that algebra helps us solve real-world scenarios. So it's our goal and it's important to make connections between the written word and math notation, taking what we can understand and turning it into an equation. So the basics, let's start off with a let statement. A let statement helps us create a variable. Let x be a value. It could be any value. So let's imagine that let x be your age. Whatever your age might be, x is going to represent that. Now we use math vocabulary and write the expression. 6 more than your age. Well, that's going to mean 6 plus x, your age x plus 6. 6 more than your age. I could also say the sum of 6 and your age. 6 plus x would be the same exact thing. I can continue with other operations and say 6 less than your age, which would mean x minus 6. I could say the product of 6 and your age, 6 times x, or your age divided by 6, x over 6, x divided by 6. Each one means the same thing. But we must caution. Adding and multiplication is commutative, so the order of where you place the variable does not matter. However, subtraction and division are not. So if we take a look at a specific example, we know that 6 minus x is not the same as x minus 6. 6 divided by x is not the same as x divided by 6. To look at this in the written word, 6 minus your age is going to be different than your age minus 6. So let's take a look at some examples and build some expressions. 4 less than a number. We'll make sure that number is x, so I could write x. As my variable, the word less signals to me subtraction, and I write minus 4. 4 less than a number would be x minus 4. So let's take a look at 6 more than 3 times a number. Now we have multiple operations, multiple things happening in one expression. 6 more than, so 6 plus 3 times a number. So 3 is going to be multiplied a number, which is our variable x. 6 more than 3 times a number, 6 plus 3x. The last one, we look at the difference of 5 and a number divided by 4. So the difference of 5 and a number. Since the number is written second, we have to look at the number being divided by 4 as the one that can be written first. The difference between 5 and a number divided by 4, x minus 4, subtract 5. The difference will signify subtraction. Now, so far, we're just writing expressions. So how do we transform the written word into an equation that we'll actually need to solve for that number, that we'll need to solve for x? So when we look at these, the word is, or forms of the word is going to mean equal to. It is going to signal to us that we need to use an equal sign. So taking a look at example 1, I look at the product of 4 and the number is 12. So the product of 4 and a number, 4 times our number, x, equals is 12. So now I have 4x equals 12. I'll divide both sides by 4, and I'll get that x equals to 3. By writing this out, I was then able to solve for the x that I needed. My next problem, 5 years ago, I was half the age I will be in 8 years. How old are you now? So now we have some complexity here. Well, 5 years ago, a minus 5, where a is your age, is equal to half the age. So 1/2 the age I will be in 8 years. So if my age right now is a, I'm going to be 8 years from now, so a plus 8. So now I've made an equation with a variable on both sides, which can be solved using multiple processes involved in algebra. I'll distribute on the right side and get a over 2 plus 4. The a minus 5 stays alone. Nothing happens to it just yet. I'll then add 5 to both sides. I'll have a equals a over 2 plus 9 alone on the right side. So now I would like to subtract a over 2 from both sides, giving me an a over 2 on the left equals 9. And since my variable has a 2 underneath it, I will multiply both sides by 2, and I will get a equals 18. So by reading carefully and setting the equation up carefully, I was able to figure out how old I am now, 18 years. My last problem is going to have us take a look at 3 consecutive numbers having a sum of 48. The key word there, consecutive, means numbers that you would count in an order. So if my first number is x, my next number would be x plus 1, because it's the next number I would say. My third number would be x plus 2, remembering that I'm going to refer to x as being my first number. Now those 3 numbers have a sum of 48, so x plus 1 plus x plus 2 have a sum of 48. Well, now that I've set up an equation, I can combine my like terms, add my 3x's, that'll give me 3x, add the 1 and the 2, that'll give me 3, and set it equal, keep it equal to 48. Now I'll subtract 3 from both sides and get a 45 on the right, and the 3x stays. And my last step would be to divide both sides by 3, and my x will equal 15. We decided that x was going to be my first number, so if my first number is 15, my second number is 16, my third number is 17. There are my 3 consecutive numbers that have a sum of 48.